All right, so this is chapter 2 of our course. This chapter deals with the chemistry of involved in biology, starting with matter, and then it talks about atoms all the way to hydrogen bonding, and you will see what this one is. So first, what is matter? Matter is anything that takes up space and has mass. So for something to be called matter, it needs to have two things. So for something to be called matter, it needs to have mass and it needs to have volume. So volume is the same as saying take up space. So if you have an object that has this volume, so let's say volume is 4 cubic decimeter, and the mass, so this one is volume, and the mass is maybe 2 kilogram. This is mass. So when you combine these two, you have matter. So anything that takes up space and has mass, or you can say anything that has mass and take up space, is called matter. So what is this matter? If we can continue, we have basic statements that we say about matter, and I think you need to write them down. So basic statements about matter. So 1, matter is made up so let me so matter is made up of particles called atoms. So if something has to be called matter, that object must have particles called atoms. If there are no atoms, that substance will not be matter. So matter is made up of particles called atoms. And these particles are in constant random motion. So these are two important statements about matter that you need to take note of. So what it means is, if you see a gas has particles, and these particles are moving. If you see a solid is also made of particles, and these particles are in motion. If I have to draw a diagram of a gas, so this is a container containing a gas. So a gas is made up of these particles, and these particles will be moving, going this way. this particle moving going this way, this particle moving going this way, this particle moving different directions. If I have to draw a particle, a solid is also made up of particles, but now these particles are close together. So these particles are called atoms. But these particles are moving, going up, down, or this way and this way. So they are moving by vibration. So matter is made up of particles. So this is a particle, and these particles are in constant random motion. So matter, normally when you talk about matter, we also talk about energy. So what is energy? Energy is the ability to do work. Ability means you can do the work. It does not mean you are doing the work, right? But if someone says, can you do some work? You can go around there and do that work. That means you have energy. And we have two laws that we talk about. We talk about the law of conservation of energy, and also the law of conservation of matter. So let's take note of that. So law, you need to write down that law of conservation of matter. So what does it say? It says matter is neither created nor destroyed. So matter is neither created nor destroyed. So you cannot create matter, you cannot destroy matter. What happens is you can just transform matter from one molecule to another. So when we talk about chemical reactions, we say that the number of molecules from one side is equal to the number of molecules on the other side of a chemical reaction. Not the number of molecules. The number of atoms from one side is equal to the number of atoms on the other side of the reaction. So based on that, based on a balanced chemical equation, so we can use a balanced chemical equation. So balanced chemical equation fulfills that. So if you remember, we talked about several laws of mass some time back, and you have a worksheet on that one. So you go back and look at that law. But we also have the law of conservation of energy. So you also need to write this one down. It says energy is neither created nor destroyed. So what this means is ngati ukaika tea mu flask. When you put tea in a thermos flask, you expect that there will be no energy coming out of the thermos flask, and there will be no energy going into the thermos flask. That's why we use a thermos flask to keep the tea hot for a long time. Why do we do that? Because a thermos flask works on the principle that matter is neither created nor destroyed. So I would say a thermos flask that is flask works using this principle. So you cannot destroy energy, you cannot create energy, you can just transform. So what you can do with energy can just transform it. So we have different types of energy. We have potential energy, we have kinetic energy. By transform, I mean you can just change from potential energy to kinetic energy. We also have chemical energy. When you eat food, you are eating chemical energy. But now when the food gets into your stomach and then it is crushed, we have a process called respiration. That process produces heat, so we are turning chemical energy to heat. That process makes us be able to speak, because we are able to speak because of the energy from food. So we have changed that energy from chemical to sound energy. And that food, that chemical energy from food, make us be able to run. So we have changed the energy from chemical energy, that is food, to mechanical energy, being able to run and the like. So that's what energy does. It is just transformed. It is not lost or it is not created. Now, when you talk about the chemistry of our substance, that's where we start from. We start from an element. What is an element? So, by definition, elements are substances that cannot be broken down to simpler substances with different properties. So, if we take carbon, carbon is an element, and the symbol of that element is C. So we cannot break down this carbon to get another carbon with different properties. Hydrogen. Hydrogen is an element. It is found as H2. So here we have two hydrogen atoms. Two hydrogen atoms to make one element of hydrogen. If we go to another element we call neon. Neon is an element that exists as a single atom. Chlorine. Chlorine is an element that exists as two atoms. So you can see Cl2. Sulfur. Sulfur is an element that exists as 8 atoms. So by definition, an element is made up of one kind of atoms. So an element can comprise only one atom or several atoms. So an element can comprise only one atom, like neon there, or two or more similar atoms like chlorine and hydrogen. So for something to qualify as an element, it should have only a single type of atoms. It can either be one atom, two atoms, three atoms. It doesn't matter how many atoms, as long as it's just one type of atom. That becomes an element. So really, you can look at the definition of an element based on what we have here up here, and also you can also look at the definition of an element based on what we have here. So substances that cannot be broken down to simpler substances with different properties because they are made up of one kind of atoms. So the Earth has a lot of elements. Here we are using symbols, but I don't think you should focus on these ones, but you should focus on these. The elements that make up 95% of living organisms by weight. So we have carbon. The symbol for carbon is C. So really, when you talk about carbon, examples are things like charcoal. So charcoal is mostly carbon. So an element carbon is important. The next element is hydrogen. Hydrogen is usually found in water. Another element is nitrogen. So you need to memorize these elements. We have oxygen. Memorize them and the symbols. If I ask you what is the symbol of oxygen, you need to say O. What is the symbol of phosphorus? You need to say P. So we have carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. So these elements are important for living organisms. So they are important for living organisms. So you need to put these elements in memory. Write them down. Now, elements are made up of atoms. We can have an element that has a single atom, or we can have an element that has several atoms. And if I can show you something like this. A chlorine, that is one chlorine atom and a chlorine. So this chlorine atom, we can call it an element. While this chlorine molecule, we can also call it an element. So an element can mean one atom of a substance or several atoms of the same substance. So sometimes we use element and atom like they are the same, but they are really they may be in one way the same, but in some ways different. Because an element can also be a molecule, but it can also be an atom. So this atom here is an element. This molecule here is also an element. So what is an atom? An atom is the smallest part of an element that displays the properties of the element. So as I'm saying, chlorine will display the properties of chlorine. So this smallest part, one of the chlorines here, is the atom. So atom is always one atom of something, one atom of something. So by definition, you need to memorize this. The smallest part of an element that displays the properties of the element. So the properties of these will be displayed by the properties of this. The atoms themselves are made up of some atomic particles. So the subatomic particles, if you are asked what are the subatomic particles, we have 3 of them that we talk about. We have protons, we have neutrons. Both of these are found in what we call the nucleus of an atom. Then we have electrons. So these are found in what we call energy levels of an atom, and we'll see what that means. So what are these protons? Protons are positively charged. What does positively charged means? Positively charged means they can attract a negative. So they can attract negatives. Right? If something is positively charged, it's going to attract a negative. So protons are positively charged, while neutrons do not have charge. Electrons are negatively charged. So take note about these 3. Protons, positively charged. Neutrons, uncharged. Electrons, negatively charged. So if the charge of an atom depends on protons and electrons only. Reason: because neutrons are uncharged. Neutrons do not contribute to charge of an atom because themselves are uncharged. So this is what we are saying. The protons and neutrons are found in the middle of the atom. So this middle of the atom is known as the nucleus. So the protons and neutrons are found in the nucleus. Protons and neutrons found in the nucleus. That's where you find your protons and neutrons. The electrons here, this is called an energy level. An energy level, or sometimes called a shell. So you need to write that down. So it's known as energy level or a shell. That's where you find electrons. Now, each of these have their own atomic mass. A proton has an atomic mass of 1. A neutron has an atomic mass of 1. The electron is given an atomic mass of 0. It is not necessarily 0, but it is really very, very small mass, so we don't include it. So initially we saw that the charge of the atom depends on proton and neutron. Why? A proton is positively charged. A neutron is negatively charged. But the electron is negatively charged, but the neutron is not charged. So because of that, mass of electron will depend only, or charge of electron will depend only on the proton because it is charged, and the neutron. That is charge. But what about mass of an atom? Mass of an atom will depend only on a proton and the neutron, while charge of an atom will depend only on the proton and the electron. For the mass here, you can see that the electron has very little mass, negligible mass, that we cannot use it. So the mass will depend only on these two, because this is 1, this is 1. In terms of charge, you see the neutron has 0 charge, so we can't use it. So the charge will depend on these two. So that's the difference between the two. And also take note of the location where they are found. Now, usually when you talk about atoms, we use what we call atomic symbols. So carbon has a symbol of C. So carbon has symbol C. But carbon, if we go back, the nucleus of carbon has 6 protons. So I'll say the nucleus of carbon has 6 protons. So we'll say carbon, its nucleus has 6 protons. This is known as atomic number. So that is the number of protons. So by definition, atomic number is the number of protons an atom has. But the nucleus of carbon also has, if we add protons and neutrons, so carbon has 6 protons and 6 neutrons. Remember, these ones are found in the nucleus. So that gives a total of 12 protons and neutrons. That's why we put a 12 here. So the number of protons and neutrons is known as atomic mass. And it is always put the top side. So I'll say that is the number of protons and neutrons. We call it atomic mass. So carbon has the atomic number, that is the number of protons, has the atomic number of 6. But carbon has the atomic mass of 12 because it has 6 protons and 6 neutrons. So that's what we are saying here. You need to take note. You need to be able to define what an atomic number is and what an atomic mass is. How do you identify an atom? An atom is identified by its atomic number, not atomic mass. So an atom is identified by its atomic number, not atomic mass. So you need to write that down. So any atom that has 6 protons is a carbon. Any atom that has 6 protons, which is atomic number, is a carbon. We cannot have an atom with more than 6 protons and say this is carbon. No. Any atom that has 6 protons is a carbon. But we cannot say any atom that has a mass of 12 atomic mass units is a carbon. We cannot say that. But we are sure that the number of protons will tell us the identity of an atom, as we will see later. So where do we put these elements? These elements, we put them in what we call a periodic table. So a periodic table is just a table showing elements. So I'll say a table showing repeating properties of elements while increasing atomic numbers. So you can write down that definition. So what does a periodic table have? A periodic table has vertical columns that we call groups. For example, this column here, this vertical column is called group 1. The next column here is called group 2. I mean the next column here is group 2. The third column here is group 3, all the way to the end. So group 1, group 2, group 3, all the way to group 8 here. So these are the vertical columns. The vertical columns go up, right? Now the rows, these horizontal rows, these are horizontal rows. So I will say this one is vertical column. This one is horizontal row. So the horizontal rows are known as periods. Why do we call them periods? Because they are like cycles. So we have the first cycle here. When we are done with that cycle, we move on to this next cycle. When we are done with that cycle, we move on to this third cycle. So when we talk about a periodic table, we think about groups, that is the vertical columns, and periods, that is the horizontal rows. You need to be able to define. When I say what is a period, you just say a period are horizontal rows of the periodic table. What is a group? A group is a vertical column of the periodic table. So I'll stop here and move on to I will continue on the next video.